28, we're going to prove theorem 3.11, the perpendicular transversal theorem. So we can't use this within our proof. So we look at our given. H is parallel to K and J is perpendicular to H. That's a given. We've got that taken care of. Angle 1 is going to be congruent to angle 2 by our corresponding angles postulate. So we had two parallel lines cut by a transversal. Corresponding angles postulate says 1 and 2 are going to be congruent. The definition of angle congruence, well, if angle 1 is congruent to angle 2, then we know that their measure angles are the same. So the measure of angle 1 is going to be equal to the measure of angle 2. Now, angle 1 is a right angle. How do we know that? Well, that's just the definition of perpendicular lines. They told us they're perpendicular, so by definition of perpendicular, we know angle 1 is a right angle. Definition of a right angle, though, we know that the measure of angle 1 equals 90 degrees. A right angle is 90 degrees by definition. So how can we say that the measure of angle 2 is 90 degrees? Well, we know measure of angle 2 equals the measure of angle 1. And we know that the measure of angle 1 is 90 degrees. So now we can link the measure of angle 2 to 90 degrees. You could either say substitution, or you could also say the transitive property of equality. They kind of work hand in hand. Jumping to our last one, because we know that the measure of angle 2 is 90 degrees, we can say it's a right angle. But then we also know that angle 2 is going to be a 90 degree, a right angle. So by definition, we can say that J is perpendicular to K, because definition of perpendicular lines, angle 2 is a right angle. By definition, it's a perpendicular line. Therefore, we've shown that line J is perpendicular to line K.